Alrighty. Hello, my name is Steve Giguere. I am a cloud security advocate for Prisma Cloud by Palo Alto. If we can bring the slide deck up, then I am ready to rock, I think. Okay, this is a talk that was created based on real true events that happened starting in last May, where our open source project was, I'm going to put it in quotes, attacked. This is called What I Learned About Supply Chain Security. And if you want to learn more about me, by the way, there's a URL right there. I'm not going to talk about me. That's not important. A little pre-talk glossary just to throw out there before we get started, just in case, because every now and then I get asked questions about some of the more security-oriented lingo and some of the things that you need to know before we get into it. For example, when I say the word pwning, what does that mean? I mean, that's almost like a hacker/video game slang for dominating your opponent, which is then adapted into security to mean unauthorized control of someone else's computer or somebody else, even worse, right? Things to understand is that when I say Git, I'm talking about version control system that tracks changes to computer files or software of any kind, and that a pull request is when a contributor, potentially malicious, potentially advantageous, asks the maintainers of the main production branch to pull their changes into their environment. So that established, let's get into why this talk actually exists. Last May or April, I believe it was, we received a pull request. Hey, you know what that is now. And it was asking us to change our entire build. Now, I work on the open source project Checkoff. It has a build process like any piece of software. And someone suggested changes to the build, which is odd considering this was a first-time contributor. Strange. Well, all right, so we took a look at what it was they wanted us to change. And now, there was maybe small on your screen, but the important thing to know is that they deleted our entire build process. And they were requesting to run 2 shell commands. One was PS in order to see all the processes running. Another was M, and if you're familiar with that, to see all of our environment variables. Now, what's a little kind of scary about that is that we use a self-hosted runner, which means it's a VM or what have you running in our internal infrastructure to make this happen. Now, you can do this for a variety of reasons, costs, whatnot, but nevertheless, this is what was happening. So what this person was doing was a little bit of potentially malicious reconnaissance to find out the processes and environment running on our own internal build machine. That could be pretty dangerous for us. And our first thought was like, what are you doing, buddy? This is an open source project. Don't mess with it. It's a gift to the world. And so we thought, all right, how bad could this have been? Because we didn't let this workflow run, but we easily could have. Why could we have? And this is where our learning began. Now, going back to the whole idea of self-hosted runners, right? Is this a good idea? Turns out no. There's a really good cheat sheet by GitGuardian that says, don't just harden your runners or just don't use self-hosted runners for public repositories. But there's a lot of reasons why actually it's an advantage to do so. Just to make sure we weren't alone, I did a little search. Yeah, we're not alone. 27,000-ish people use self-hosted runners in open source projects. Okay, that doesn't mean it's good, just means it's a thing. So the next thing we need to learn about is just if you don't know what a GitHub Action workflow is, and I realize for many of you I'm preaching to the choir here, but entertain me here. GitHub Action workflows, in the words of Git, are workflows that are defined in a particular directory. That's a very special directory that can take action on the source code that you are checking in. Another perspective on this personally is that the workflows or the YAML files that define what was going to happen based on certain triggers in this directory, it's almost an entirely different application designed to run on your application. Think of it that way. And in a sense, it needs to be secured as well, independent of maybe those actions might be security checks for your other application, right? It's a bit meta, but it's important. GitHub has a few suggestions of how you can use workflows, build and test pull requests. Again, this is straight out of GitHub documentation. Deploy your application, add a label every time someone opens a new issue. Yes, GitHub and GitLab and other workflows handle issue management as well, so pretty cool. One that I added here for my own purposes is that sanitization of metadata. So maybe issue title, PR title, just to make sure it's in a certain format. I've seen plenty of examples of that, and we'll look at that shortly. So what's wrong with this? The fundamental supply chain issues that you get from this are that GitHub can and often will run new workflows committed into that path, even if they are the committed files. And this is pre-review, pre-approval. So when that person tried to submit that workflow file, it may have run, if not for a few basic risk mitigations already built into GitHub, and I'll talk about those in a moment. Secondly, metadata like issue name, issue description, or even PR name, there's a lot of metadata that gets handed to workflows. These are often used, I've seen in workflows, as unsanitized input, classic application security problem. And then the final is that the workflow directory, which is in a way, as I said, an independent application, has the same access controls as everything else. And ideally, this is not a great thing. And we started to think, all right, well, based on realizing this, how could we learn from this experience and abuse ourselves, which sounds bad, before someone does it to us? Now, if we take these three use cases, how can we abuse these? If no one's sanitizing an issue title, can we somehow work some kind of command injection to exploit existing workflows? Maybe. If we know that we're building and testing pull requests, can we do something to the pull request by abusing the power of the GitHub token? Could I submit my own workflow, very much like what this person tried to do to us, to execute my own commands? And then similarly, but with a slightly different perspective, if I'm deploying an application, are there credentials in this workflow? Have people stored AWS keys or maybe a Kubernetes kubeconfig as a secret? Can I get access to that? So we started exploring these options. Now, the first instance, the reason it didn't work is that if you're a new contributor to a GitHub, the default is that it won't run the workflow. It will, in fact, pop up this little button called Approve and Run, which we did not click, thankfully. And that only happens for first-time contributors by default. Now, if you do click on the little Learn More that's kind of fuzzed out there, it will take you to the documentation that warns you about GitHub workflows. It says, hey, whoa, wait, check, make sure that what's being checked in isn't a workflow itself. Because normally it's almost like an anti-pattern. You want to click that button because typically your workflows have security checks in them. And you want to check it. So you might just click it by accident, right? All right, let's keep that in mind. Or, and I don't mean this to be the wrong kind of advice, but just more of an awareness to you, everyone who has GitHub or GitLab, all of this applies to both. First-time contributors, how do I become a first-time contributor to a repo? It's pretty easy. I could change the README. I could be a first-time contributor to a easy first issue. I could be a force for good. It's not hard. And suddenly that button will not come up anymore. As I said, because the defaults require approval only for first-time contributors. All right. Let us take a look at our first scenario about abuse. Now, unsanitized input was the first one we talked about. I started looking around to see how this metadata gets used, and I found this one example, which was interesting. Now, we didn't play with it in this particular example, but the idea that a GitHub event issue is being saved as a blog post by a workflow. Of course, our minds got going, okay, well, if this is being used in a blog post, can I just make my workflow title some basic HTML? I only have 256 characters for a title, but I'm pretty positive I can make a pop-up fake login in 256 characters. In fact, I'm 100% positive it's possible. Or perhaps worse, I saw this example thousands of times, and it was just using the issue title in a bash script. Maybe to sanitize it, maybe to store it, maybe to do something with it. There are lots of examples just like this. And so we did create our own example of this, and we passed in as an issue title this command. And now why would this work? It's because the metadata is being used in quotes after the run, which is a bash script, which means if it's bash and I put my command in backticks, try and get those on screen, backticks, then it will resolve that, hence execute. And now I have remote code execution. So what happened when we did this? We created our issue. It ran the workflow that handled it. And our receiving URL, which in this case is webhook.site, great URL for testing API calls or curls, received all of the environment variables for our runner. Dangerous. It wasn't that hard. Actually, probably easier than what our attacker tried on us. Now, there are ways to try and protect your internal environment, but there really isn't a way completely to test a misuse of that kind of metadata. There should be ways to test it. I think it's something that we're working on here, but there are ways like environmental protection rules to protect things like secrets based on environments. I highly recommend reading that or Googling it. By the way, there's a link at the bottom of this. My final page has every link I reference on it. So if you're thinking, oh, I'll screen capture something, wait till the end. Second piece of advice, just don't put credentials in your pipeline ever. Not as environment variables, not as secrets. If you have to communicate to an outside source, use things like OpenID Connect, use assume roles. There's a little example there and some other links that can help you. But if you have to do anything, make sure it's a short-lived token. But ideally, just don't use metadata like that in your workflows. All right, here's scenario 2, GitHub token abuse. Now, I have to start, I'd be remiss if I wasn't introducing branch protection rules. This is your bread and butter for security within GitHub. Obviously, there are equivalent things within CircleCI and GitLab as well. But you should always have branch protection turned on for your production branch. Always, 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 always. Almost every tick box in there should be ticked. Now, I have to say that the defaults for all the tick boxes aren't always perfect. Like this is one such example. This particular hack was actually discovered by a company called Cider Security, which conveniently Palo Alto recently acquired, and they're now my colleagues. So we get to work together on these kind of things, which is amazing. But what was noticeable was that if you turned on pull request before merging and approvals, the default was this tiny little 1. Really, it should be more than 1. So how could we take advantage of this? Well, if we understand the default settings for our GitHub token, and we look at our workflow permissions, we realize that a GitHub token has a lot of power by default. In fact, these are the default workflow permissions here. Read and write permission on the entire repository? Really? GitHub Actions can create or approve pull requests? No. Yes, they can by default. Obviously, the best default would be to just have read repository contents permission. And it's worth checking your repository to make sure you've changed this. Because let's find out what could happen. If you look at the default access, if you do the good thing, you really only have read contents and read metadata access, which is all you need for 99.999% of your workflows. If you don't, you have all this access, which is kind of everything. You can't approve a pull request, or you can't merge a pull request. That's what I should say. You can't do really extreme things, but you can do a lot. It's amazing. Now, the hack that Cider did was they created a curl within a pull request that basically called the GitHub API from inside. The call is coming from inside the house. And based on the metadata that was provided, GitHub repository, event number, which is the pull request number, and the GitHub token, they were able to auto-approve their own pull request, which was amazing. All right, a little cautionary tale before we get too far into this about using personal access tokens. I'm actually, the reason I don't type this stuff out is because I want you to know that this is in the GitHub documentation. Now, GitHub is very secureable, but sometimes some of the advice you see is not ideal. For example, if it's saying in a workflow, if you need additional permissions, to create a personal access token and store it as a secret. Now, what did I say earlier about storing things as secrets? Maybe not good, right? Imagine this little scenario here that plays out. When I saw some advice suggesting creating personal access tokens, I went on a little hunt for the suggested use of personal access tokens, and I found a GitHub action that created some cool logic around auto-merge pull requests. Now, we know that a GitHub token can't do that, so you need a path. So I went searching, and I found one. But okay, well, the next step, if I know whoever uses this has to have a personal access token, then I looked for one. I found lots of people, in particular an NPM module that was using it. Now, what if I could get that personal access token through a workflow attack on that particular NPM module, knowing that I can approve and merge via the GitHub token and the path means I could add malicious code without anybody ever seeing it. And from there, I have a supply chain attack downstream on anybody who uses that NPM module, which can be bad. Just a little word of warning. All right, let's call it the big finish, pwning the runner. This is about as far as we went, but it was pretty far. Created a workflow. Now it was going to run because I did something kind, and I'm now part of the repo, so I'm not a first-time contributor. I created 2 repos, and I committed this workflow to my second repo to see what would happen. Now let's zoom in on this because it's a little small. Okay, here we go. We can see here that I've got, actually, I'll do it even more. I like the response from the tech crew to zoom in on me even more so. This is cool. So I'm going to run a few commands within a run, so in a shell. Now in order to get access to the secrets, because they're not really an environment variable, they're only available to the workflow in an odd format by putting the curly brackets. So I make them available by echoing them to a file. Then I run my curl and I push it to my malicious destination. And then I do what I did before with the issue title. I run the same thing to get my environment variables, push it to the same location. Now I've got secrets and I've got environment variables. And just for kicks, I threw this in here. Now, if you're interested in security, a bit of a geek like me, you might look at this and go, what? Oh, this is what we call a reverse shell. This is me running a shell within a shell, and I'm sending the shell out to another malicious location. Now, the reason I wanted to do this was so I could keep the workflow alive. But then I started to think, well, once it's alive, what else could I do? So let's take a look at what happens when I try and do this. Now, this is a video, so we're all crossing our fingers and hoping this plays. Here we go. All right. So this is the recording of what actually happened. I've got two particular workflow GitHub accounts. Now, the baddie obviously has the black screen here. So the baddie who has become a contributor is going to go into the workflows account and suggest a new workflow, which, because I'm not a first-time contributor, we know is going to run. So I'm going to call my new workflow pwn.yaml. If you're like a hacker, don't call it that. That's pretty obvious. And this is, for educational purposes, we're going to make things really obvious. And there are those three commands, the curl, the env, and the reverse shell down there. And just for kicks, I actually put the auto approve up there as well. Now, I don't need that, but it's there. Now, below you can see that I have branch protection turned on because I'm a good person. So I need to create a new branch and a pull request. Fantastic. So I'm going to create a new called innocent workflows. I'm going to propose this new file real quick. And then it's going to ask me to, and then I'm going to do this. I created a receiver for the reverse shell. That probably seems a little bit odd, but that's somewhere, in reality, I did that off in a separate VM. So now I create my pull request. Great. Everything's being processed, right? You can see I need a review, and I can see my workflow is waiting to run. So the big CI22 is my workflow. And look, the approval got approved. Who approved it? The GitHub Actions bot. Well, that's not good. And you can also see that my workflow is running. Amazing. Did all of my little malicious attacks work? They did. I have the token. I have the environment variables. And what turned out to be a lot worse, of course, was that, look over here, that my receiver actually has a shell. And this is on the runner. Now imagine this is my self-hosted runner. Pretty bad, right? I'm going to make it a little bit more readable by using a bit of Python. We can see that my identity is runner. Probably not a lot of privilege for the identity runner. And I can see the files that are in there. And I started to think, wow, what can I do here? And I worked at it for a little while. Now let's remember, this pull request is open and it's waiting for this workflow to finish. Okay, let's go back over to our shell, and we'll just leave that up there because we're going to have to rush back to it in a moment. All right, I'm going to run a little script. I know a lot of stuff's going to go by real fast. But the important thing is I started manipulating this live pull request remotely, and it's now closed. How weird is that? What happened? You can see it's not there anymore. If we go and look at closed pull requests, so we can take a closer look, and we look into, there's the last one, create pull.yaml. You can see I did a few previous test runs, of course. And we look at the files changed. Oh, what did I do? It's broken. Let's look at the commit. Is it my pwn.yaml? No. It's Linus Torvalds, famous creator of the Linux operating system, has committed something that says, hi, what on earth is going on here? I've done all sorts of strange stuff, but essentially what I've done is I've completely covered this. And if I go back over now, this is already looking dodgy. And I still have access to the runner. Who am I? I am runner on the runner. well, now that I'm resident, I wonder what else I could do. Now I'm going to end with one little tiny little change and one danger item that on runners, on VMs, unfortunately, that doesn't work here. Never mind that. Unfortunately, people have Docker installed by default. Docker is dangerous because its daemon runs as root. So it's not that hard for me to do a Docker command, and suddenly I have elevated myself to root on a private runner, which is not good. So let's end our maliciousness there and check out our result here. What just happened? Through a workflow attack that I learned how to do, I exfiltrated all secrets, potentially a personal access token. I got environment details. I'm persistent on the runner now, and I elevated myself to root. In addition, I was able to cover my tracks. How was I able to do that? Well, let's talk about good advice. In addition to what else I could have done, things I didn't do on this runner. Well, there's been other investigations have indicated that runners have a tendency to have more access or privilege than they should, because no one expects them ever to get access to them. Runners have access to S3 buckets. They have access to ECR to registries generally. Sometimes those registries don't have immutable tags, which means I could replace an image of my malicious image with the same tag. Is there a VPC? Do I have IAM access? Do I have access to cloud metadata? There's a lot of additional reconnaissance I could do in addition to just being root. So we need to talk about prevention. Now, we've already learned a lot on the way through. Applying what we learned. So you're probably already thinking, do not run workflows unless you're 100% sure. Change the defaults away from first-time checks to all outside contribution. Make it as restrictive as possible. Remember, self-hosted runners look like they're being targeted at the moment, so be careful. And always have your branch protection, including administrators, turned on with more than one reviewer. I think these are the things we've already learned. I've introduced you to environmental protection, and read the GitHub hardening guide. I think, as developers on a repo that has relative maturity, it took a long time before we really got to the point where we really thoroughly read that. Do not add any kind of permissive tokens. If you do, short lifespan, least privilege, all of the good things about security. Using OpenID Connect, relatively new, read into that. And obviously use all logs possible. Now, I haven't mentioned this. Code owners is a way of specifying what approvers can approve content to a particular directory. Rather than the GitHub action token to be able to approve that, I could have used a code owners file in my .GitHub directory to say only Matt could approve anything that goes into this. So it changes the permissions, that problem I specified early on. And then finally, enforcing signed commits. We're a little bit cavalier in the open source industry about signed commits. We should use signed commits, and we don't. Otherwise, you might find yourself getting pwned by Linus Torvalds. Final notes on automation. OpenSSF Scorecard has ways of checking your repo for a lot of the things I've mentioned. Out of the box, it's free. In addition, the result of this research was to add similar checks to checkoff. So go grab both of those for free. Here are all the links that I used. If you want to grab a screen capture, now's the time. That is the end. I hope you enjoyed that. I'm sorry if I overran. You can ask me questions in the chat.
All right, Steve, thank you so much. This should be mandatory. If you use GitHub, you need to see this. You need to see this video. I'm going to remind that a couple of times. Beautifully done. And you seem like such a nice guy, and you have all this news. So we're going to open up the Q&A and just kind of remind everybody, we have a little extra time. You're actually a little early, but we have some time for some Q&A.
But just to reiterate what Mark just said on this should be mandatory information for everybody who is using GitHub, just based on the comments right now on the chat, this information that you just shared was found extremely valuable. And I guess somebody also said that, wow, this was actually kind of scary to hear as well.
It was scary for us to experience it.
Yeah. So we've got lots of applause, but let's see if we have some questions for... First question, Enrico Walther wants to know, it's impressive. Do you think this applies also to GitLab CI?
It does. Actually, we did a lot of the same checks simultaneously on GitHub and GitLab, because GitLab has a lot of the same similar patterns in terms of creating workflows. Just the names are different. But a lot of the things I was able to do, particularly that final hack, I was still able to do on GitLab.
All right.
Yes. So the next question we have here is that can the owner of the repo get access to the GitHub runner for debugging?
It depends on what the runner is and where it lives. The example I actually did, I used a real GitHub runner. I didn't use a self-hosted one. If it's a self-hosted, it can be, even though it's advised not to use self-hosted runners, you can have a lot more security on it you can apply to that runner. So you could be running all sorts of observability on that. See, if a shell opens up on it, you should be alarm bell should be ringing, because that shouldn't happen on a full automated VM.
Okay. I think that's all we've got thus far.
I think we have one more.
Oh, here we go.
Yes. As DevSecOps, what kind of security training we need to follow? What would you recommend?
DevSecOps security training.
Yes.
DevSecOps security training is actually in short supply, which is why we create talks like this, because there isn't like you can go do a degree in DevSecOps training. I think there are really great sites out there. For example, there's one called We Hack Purple, which is a great site that has entirely free training. So that's the immediate thing that comes to mind. If you want to learn more about DevSecOps and you want to do it for free, I highly recommend that.
Okay. Thank you. Stuart Johnson would like to know, do you think the risk profile changes when some other container configuration is used, like Podman?
100%. Docker is dangerous. If you're using Podman, highly recommended. Great advice, Stuart Johnson. Thank you for bringing that up. There's no way I could have gone to root at the end of that if I were using Podman.
I'm going to mention one thing that I kind of noticed here is you used the word hacking, and for some reason I just moved. We bought a little farm, and when I moved, Richard Stallman's essays book was the only book that I could find to put on my bedside table to lull me into sleep every night. And he used the term hacking as the good guys and crackers as the bad guys. So which are you, Steve? Are you a hacker or a cracker?
I'm a white hat. I call a hacker. Let's call it that. Researcher / I don't know. Yeah, let's be the good guy.
Okay, I believe in you.
Thank
you. Cool. Let's see. Risk profile. Any books on DevSecOps? We're not going to get this kind of stuff from anybody but people like you, Steve, are we?
There's a really good book written by a friend of mine, Andrew Martin, and his colleague, Michael Hausenblau. It's called Hacking Kubernetes. It's fantastic. And it has a attacker-defender perspective on not just Kubernetes, but cloud-native security generally. I think it's fantastic. And it's entertaining. It's written as if they have the Red Pirate, and they created all these characters around it, so a bit gamified. It's very, very good. The founder of We Hack Purple, Tanya, she wrote Alice and Bob Learn Security, which is another great book. And finally, Liz Rice, who I think is in this conference, wrote Container Security. So these are all amazing references.
Yep. Amazing work. That was really cool. Okay. I think that is most of what we have got. Any final questions for Steve? This is a once-in-a-lifetime opportunity for some of you. I think that must be all.
Yes.
All right.
Excellent.
Thanks again, Steve. We absolutely applaud you.
Yes,
that was really, really wonderful.
Thank you very much.
Yes.
All right. Please you enjoyed it. My pleasure.
Hi, we're from Efficode, the proud organizer of the DevOps conference.
Our goal is to uncover cutting-edge talks, emerging ideas, and DevOps trends, providing a global forum for practitioners and decision-makers to learn and grow.
We would love to also explore how we can help you excel in DevOps together. Visit us at efficode.com and enjoy the inspiring talks at the DevOps conference.